12.4 Combined Gas Law. Chapter 12.4 looks at combined gas laws. And what we're going to be doing, just kind of reminding everyone, the units, okay, that are interchangeable, these are STP. Understand that sometimes I might not give you your pressure, but I might use the letters. We are at STP, which means that if we're at STP, we are using any one of those numbers. Okay, and understand that our temperature, if we need to use temperature, our temperature, if we're at STP, we're referring to it being at 0 degrees Celsius. Okay, now we have something that is referred to as the standard standard ambient temperature and pressure, and this value is, our P value is no longer 101.3, it's actually at 100 kilopascals evenly, and the temperature when it's at SATP is 25 degrees Celsius. So be aware that sometimes I might not give you the values, but I might use the letters STP or SATP when in fact I am asking you to use one of these for your pressure unit. I'm asking you to use this for, let's say, one of your temperature units. Or I might ask you at SATP where one of the temperature units will be that one and your pressure being that one. So that's why it's important. Do the homework questions, practice so you can see exactly what I'm being asked to do. You've got to practice, because if you're not going through the homework questions, when you get an evaluation, you get that test, you get that quiz, you get that final exam, you're not going to know where to start. It makes sense why you don't know how to start, because you've never practiced doing any of these questions. Okay, and don't just do the sample problems. It's not enough. You got to do some of the homework questions. Then understand that on the website, I've got all the answers. In the Google Classroom, I've got all the answers for them, and they're in great detail answers. So it's not just here's the answer, figure out how I got there. I actually show you how we got there. Anyhow, here's just a recap of the laws that we've seen. So we've looked at Boyle's law. Boyle's law looked at volume and pressure changes when temperature remained constant. Okay. Charles' law looked at volume and temperature changes if pressure remained constant. Okay. And lastly, Gay-Lussac's law looked at volume, okay, remaining constant, but we're looking at temperature and pressure changes. Okay, so what we looked at is we looked at all of these formulas. We've looked at this formula, looked at this formula, and we've looked at this formula. And what we can do is we can put this whole formula all together. And when we put it all together, okay, when we put it all together, if you look at it, you can put it all together using Boyle's law. Because look at this. We've got pressure on top of temperature. We've got volume on top of temperature. So couldn't we put T1 down here and T2 down here? And when we do that, we form what is referred to as the combined gas law. So none of the values are considered constant, because they're all changing. Now, here's the thing. It's good to know Boyle's law, Charles' law, Gay-Lussac's law. But for argument's sake here, technically, you could use this formula for every one of the questions that we've done. So take, for example, the earlier sample problems where we were, and when I asked you to do that list, let's list, okay, we've got V1, we've got a T1, we've got a V2. Oh, it's asking us to find T2. Why couldn't we use this formula? Okay, we could technically, okay? It's improper, but you could technically, right? So what you're going to do is this. We are going to ignore the values here, okay, or the variables that we're not using. We're not using pressure. Why? Because if we're using this here, we are assuming, according to Charles's law, that pressure remains constant. So pressure remains unchanged. So all of a sudden now, here is Charles's law, right? V1 over T1 is equal to V2 over T2. So when we have that, we could solve that problem. And all we're trying to remember is really one equation. Okay, so you could technically use this to do pretty much all of these types of calculations that we looked at today. Okay, but just remember to exclude them from don't put in your P1 and P2, right? Just remove them completely. Okay. So here we've got just a couple of sample problems at the end. Okay, so we're going to look at just one sample problem before we wrap up for tonight. As you read the question, right, you list all the information here. We've got a P1, T1, V1, P2, T2. We're being asked to find the V2. So it says what will happen to the volume. Okay, so we're looking for the final volume. So we have our combined gas law. We substitute. What I did was I rearranged the formula to isolate what I'm looking for. It doesn't really matter how you go about solving it. But remember that if you do use the units, it's very good to find out if you in fact need to convert a unit, right? Because here's the thing. Here's a little trick. Okay, so let's look here. So we've got kilopascals. Good. I can cross that out. Don't need to convert any of those units. I've got Kelvin. Oh, that cancels out. That cancels out. And the only unit that's left is liters, which lets me know what my final units are supposed to be in. It's a great tool to use. Use the units, because by using the units, it allows you to see, did I have to change? Because what happens is this. Technically, here's one of the pressure units. I give you 103 kilopascals. But what if I gave you this as 756 torr? And you substitute it into this formula. Okay, so we substituted into this formula here. Okay, so we're going to substitute it here, 760 torr. Okay, as this is a hypothetical right here. Look at this. This torr unit is not going to cross out with kilopascals, which means I need to convert one of them. You choose which one you want to convert. Okay, in a scenario like that, you either convert the kilopascals to the torr so that these two match, or you convert this torr to kilopascals so that these two units will match to allow you to cross them out. Okay, so I can't stress enough, do as many of the practice problems as possible so that you understand what all this means. And again, make sure that it makes sense, right? Using Boyle's law, Charles' law, Gay-Lussac's law, as one goes up, does the other go down? Boyle's law. Because remember, Boyle's law is the only one. Okay, Boyle's law is the only one. Oops, there it is. Okay, Boyle's law is the only one that is actually an inverse proportionality. All of these here are a direct, okay, proportionality. Why? Because they're both being divided. There's division. While up at the top, they're being multiplied. So here, as one goes up, the other goes down. But according to Charles and Gay-Lussac's, if one goes down, so does the other. If one goes up, so does the other. That's what we mean by the direct proportionality and the inverse proportionality. I hope you liked this video. If you did, do not be shy to hit that thumbs up button. And while you're clicking the thumbs up, click on that subscribe to stay tuned to my new videos. Thanks for watching.